Hey guys, so I wanted to go through and make a video today about a quiz problem from week 2 that seemed to be a little bit trickier, and so we wanted to make sure you knew how to do this one in case it showed up on the exam. So you can kind of see it in the background here. It says determine all boundary points and solve the polynomial inequality, and you have, in this case, x minus 5 times x plus 7 times x minus 7 is greater than or equal to 0, so we're going to go through how to solve that one today. So here we have x minus 5 times x plus 7 times x minus 7 is greater than or equal to 0. So the first thing that you have to figure out is what your boundary points are. Well, each term you have here is going to be a boundary point. So the process on that is you just set all of these equal to 0 and solve for each x, and you'll find your boundary points. And so you'll just use the zero product property to do that. And in each case, you literally just solve for x. By moving all the constant coefficients to the right-hand side. So in this case, we have x equals 5. This case, we have x equals negative 7. And then in this final case, we have x equals positive 7, or just 7. So those are our boundary points for the inequality. Now, the idea is that you have to put them on a number line and do some testing to see which interval makes your inequality true. So in this case, we're going to put negative 7 over here. We'll put 5 somewhere around here and positive 7 somewhere around here. So we have 1, 2, 3, 4 intervals that we have to test. So we'll just take random values within those intervals, plug them into our original inequality, and see which one makes the inequality true, and that will be part of our solution. So in this case, I'm going to do negative 8. I'll do a 0 here. I'll do 6 here, and I'll do 8 here. Oh, and the other thing too that you want to pay attention to is this greater than or equals to sign. So that tells us that these points, these boundary points, will actually be included, and so they'll be represented with a filled-in circle, which in our final solution we will use brackets to represent that. So that's something to note here too. Okay, so we're going to start by plugging negative 8 into our inequality and seeing or evaluating what happens. So negative 8 plus 7, negative 8 minus 7. Now it's not so much about the numbers or the values you end up with, it's about whether it turns negative or positive. So in this case we have a negative in the first section. Second section we have a negative. Third section we have a negative. So we have 3 negatives, which if it were 2 it'd turn positive, right? But we have 3 negatives, so this whole interval is going to be negative, which means that it is not going to be part of our solution. It is not greater than or equal to 0. It would be less than or equal to 0, right? So now we're going to go to the next one. So we're going to do 0. 0 minus 5. 0 plus 7. 0 minus 7. Greater than or equal to 0. So in this case we have a negative, we have a positive, and we have a negative. Well, look at that. We actually have a positive value here, right? Because a negative times a negative is a positive, and we have our third value as a positive. So that one is going to be greater than or equal to 0. So that whole interval is positive. So now we're going to go into the next one, so 6. So 6 minus 5. 6 plus 7, 6 minus 7. And is that greater than or equal to 0? Well, in this case, we have a positive. We have a positive. But then this last one, we have 6 minus 7, which is negative. So we have one negative value in that, which means that whole interval is going to be negative. So that's not going to be part of our solution. So now we're going to do our last one. We're going to test for 8. I'm running out of space, sorry guys. So we'll have 8 minus 5, 8 plus 7, and 8 minus 7. And is that greater than or equal to 0? Well, in this first case, we have a positive, because 8 minus 5 is still a positive number. 8 plus 7 is a positive number. 8 minus 7 is a positive number. So in this final case, we have that it is a positive interval, and it will be part of our solution. So therefore, let's change colors here. Do this color. So therefore, our entire for our solution, it is going to be this interval to this interval using brackets, and then this interval to infinity. Infinity is always represented with parentheses, so you don't ever have to worry about that one needing brackets. And so our final solution, though it's kind of squished in here, will be -7 to +5, both in brackets. Let me try to do that again. -7. +5 union, because it's basically saying we're jumping over this interval here that makes our inequality inaccurate. And then we'll go from 7, comma, infinity. And again, infinity is always represented with a bracket. And that's it. That's how you solve this one. If you have any questions, please feel free to reach out, and thanks for watching.